Ditch the spreadsheets. Large language models are here to revolutionize the way you work. Hello, hello, hello. Cornelius Fichtner from PMPrepCast.com/AI here to bring you up to speed on large language models. And here is what you can look forward to. By the end of this lesson, you will be able to describe the essentials of large language models, including their differentiation from models like GPT, the critical role of data in their effectiveness, and their practical application in improving project management tasks. We're going to achieve that with this agenda here, by starting with a definition, looking at what large really means, learning what happens from initiation to closing on an LLM training project. I'll explain how these models find the right words that might be missing in a sentence, and how LLMs and GPTs are related. And before we do the takeaways, I'll bring out my crystal ball to look 15 years into the future to paint a world where LLMs are a powerful ally by our side. I often start this slide here with a sentence similar to, before we get into the thick of it all, you may be wondering ... But this time round, it is actually me who was wondering. I was thinking to myself, do we really need a lesson on large language models? Because they are so complex and technical, and the depth, I was wondering, LLMs might be too advanced and perhaps not directly applicable for project managers focused on practical day-to-day management tasks. However, understanding LLMs can provide us project managers with insights into how AI can optimize workflows, automate routine tasks, and generate innovative solutions for complex problems. And knowing about these models enables you and me to better evaluate AI tools for project management, and knowing about them means that you can make informed decisions and incorporate AI technologies into your projects. And also, there is this here. As you can see, large language models, that's the red dot there in the center, they are at the intersection of several key areas within the broader AI sphere. This diagram illustrates that LLMs and generative AI have become a central pillar in the AI ecosystem, intersecting with natural language processing and machine learning, and even touching on areas like computer vision. That's sort of the purplish pink circle at the bottom there. From a project management perspective, the central positioning of LLMs in this AI landscape underscores their versatility and transformative power across various applications. For you and I, this central role means that gaining familiarity with LLMs could be crucial for understanding and harnessing AI's future potential to enhance communication, automate reporting, and streamline decision-making processes in our projects. Here is the definition from Wikipedia. A large language model, LLM, is a language model notable for its ability to achieve general-purpose language generation and understanding. LLMs acquire these abilities by learning statistical relationships from text documents during a computationally intensive, self-supervised and semi-supervised training process. We'll get more into the inner workings in just a bit. Right now, I want to start with a few high-level insights for you. So, a large language model is built on neural networks, which are complex algorithms mimicking the human brain to process and learn from vast amounts of data. These are truly enormous data sets, encompassing a wide range of internet text to understand and generate human-like language. And this means that the training cost for a large language model is typically high due to the extensive computational resources required to process that massive data set. LLMs excel in NLP tasks. That's natural language processing, enabling them to understand, interpret, and generate human language in a contextually relevant manner. And then here's a term to remember, if you like. It is zero-shot learning. This term describes how large language models can perform tasks without explicit examples in the training data, showcasing their ability to also generalize knowledge. Scalability is a key feature, allowing LLMs to handle increasing amounts of data and more complex tasks without compromising performance. While traditionally models are static post-training, the concept of continuous learning aims to update and improve LLMs as they are exposed to new information over time. And with that, you already have a pretty decent grasp of what a large language model is, but let me summarize it for you. Well, summarize is a big word for a long text like this. Anyway, here it goes. Large language models learn to generate text by training on massive amounts of data. This training involves breaking down the data into smaller units, tokens, assign numerical representations to these tokens, encoding and analyzing the statistical relationships between them. By capturing these relationships and learning the semantic connections between words through techniques like word embeddings, LLMs can predict the next word in a sentence, enabling them to produce coherent and contextually relevant responses. All right, let's begin at the beginning here. What exactly do we mean by massive amounts of data? Well, to put it mildly, the number of datasets used to train these models are staggeringly, mind-bogglingly large. The primary measure of size is parameters, and parameters refers to, and I quote here, the total count of trainable weights within the neural network, whatever that means. Simply put, it is the number one indicator of the model's complexity and capacity to learn from data. Larger models with more parameters can capture more nuanced patterns in the data, but require more computational power to train and run. There are 4 more measures. Let me show you in a table. Here we go. In this table, we have 5 randomly selected large language models at the top and the measures on the left. From the top down, they are number of parameters in billion, dataset size in terabyte, training time, computational resources, and the memory footprint. Unfortunately, while all the models proudly talk about the number of parameters, the rest is pretty much undisclosed. So let's not dwell here too long and just zoom in on 2 things. At the time of recording, Megatron Turing is the largest. And not just by a little, but it's 3 times larger than its closest competitor. And the training time, while an estimate here, is also staggering. It takes months for most of the models to ingest, process, and learn from their training data. Overall, you and I, we could probably live out our lives very comfortably on the money that's being invested here. This screenshot here from an article on Wired magazine is the reason why on the previous slide I said at the time of recording, because at the time just before recording earlier this morning, this article here popped up in my news feed inside the creation of the world's most powerful open source AI model. Startup Databricks just released DBRX, the most powerful open source large language model yet, eclipsing Meta's Llama 2. And I don't even have Meta's Llama 2 in the table. So things are not static, things are moving, things are getting bigger. So if you're watching this lesson anytime after I'm recording it, then the table from the previous screen is probably already outdated and there are larger models out there. Next, allow me to embark on an extremely basic journey through the evolution of LLM in AI. Initially, AI was about foundational algorithms and simple tasks operating on rule-based logic to perform specific predefined functions. AI then progressed to early natural language processing, starting to parse text and make initial strides in understanding language patterns and translating between languages. Today, LLMs demonstrate an advanced grasp of language nuances, capable of engaging in complex conversations and generating coherent text across various applications, symbolizing the pinnacle of AI evolution so far. So, our modern LLMs mark a significant leap from initial AI models, offering nuanced understanding and generation of human language. These models go beyond keywords, grasping the full context, achieving human-like text and language. More than that, within seconds, LLMs can produce complex documents, conversations, and analyses showcasing their advanced generative abilities. As you can and will see, in our current journey, large language models stand at the forefront, not just as a technological achievement, but as the backbone of intelligent systems that shape our digital conversations and decision-making processes. Here are 3 areas where LLMs and their capability to understand and generate language can be helpful for us project managers. In the project planning phase, LLMs interpret natural language inputs, organizing complex project requirements into structured formats. This ensures all team members have a clear understanding of project goals and tasks. This could be a work breakdown structure or user stories from all this input. Throughout the projects, LLMs provide back-end support to brainstorming sessions by synthesizing information across project documents, generating creative solutions to challenges as well. This sparks innovation and problem-solving within project teams. And once your Zoom or Microsoft Teams meeting is over, LLMs analyze the discussion, the transcript, to identify and summarize action items, crafting clear task lists for follow-up. This enhances team accountability and project progress tracking. But before it can do any of this, we have to train it. And training it, well, that's a project. And since this is a project, let's see how this could be executed by following the traditional 5 stages of a project. So, in initiation, we are setting the stage for our LLM by first defining the exact goal. In our case, it needs to be specifically designed to support project managers and teams with day-to-day project-related tasks. This clarifies the scope and the purpose of our AI journey and training. During planning, we plan and strategically gather diverse data sets encompassing project plans, reports, communications, and management strategies to train our LLM, ensuring that it aligns with project management needs. And in executing, we focus on training our LLM with the collected and cleaned data, utilizing advanced algorithms to equip the model with the capability to understand and assist in project management tasks. And by the way, most of today's LLMs, they train in 2 steps. First, the model is pre-trained, which means it's given a large data set of text to form some basic understanding of patterns of language. Pre-training datasets often consists of trillions of words. After pre-training, the model is now capable of generating some output, but the output is rough and often machine-like. It's not polished or conversational. Optimization then happens in the second step through supervised learning processes that adjust weights in the network to improve the model's ability to respond. And in our project here, I have scheduled this second step in our next project phase. And that is, of course, monitoring and controlling. Here we refine our LLM not only through continuous fine-tuning, but also through validation and evaluation, ensuring its outputs are practical and relevant for project management scenarios, enhancing its precision and usefulness. Often, this is done through reinforcement learning from human feedback. Reinforcement learning from human feedback, RLHF, where humans tell the model how to improve output via ranking and rewriting of model responses. And then finally, we deploy our LLM, rigorously testing it and using it on a pilot project to validate its effectiveness in assisting project managers and teams with their day-to-day tasks. Well, I said finally, but that's not quite true, because we cannot forget operations, as our LLM is actively used by us and the team. We focus on continuous improvement by analyzing feedback and performance data. We refine and update the model to better meet the evolving needs of project managers and teams, ensuring that our LLM remains a cutting-edge tool for managing day-to-day project activities. And while this is only one of many potential scenarios of how such an AI training project might go down, it gives you a basic idea. Because frankly, the easier and faster way of doing it would be to take a model from somebody else, a pre-trained model, and then fine-tune that particular model using whatever project management information and data sets you have available within your organization. And that is pretty much what PMI did when they created PMI Infinity. They took the OpenAI model, that's ChatGPT, and then they fine-tuned it and trained it with all the data sets that PMI has at its disposal. But my intention here was to give you a general overview how a training of an AI model is done. Next, I want to zoom in on just the aspect of model training, where we have pre-training and fine-tuning. Pre-training involves exposing the LLM to a vast array of text, mostly general, everyday language, possibly even with some project management articles, methodologies, and standards, ensuring a broad understanding of language. And this phase allows the LLM to learn grammar, syntax, semantics that are crucial for managing language effectively. By analyzing text without specific guidance, the model uncovers patterns that are relevant to communication. Tasks like predict the next word then train the LLM to generate coherent sentences, including project plans and reports. Regularly updating its parameters, the LLM refines its ability to deliver precise project management advice, albeit still with a machine-like feel to it. Fine-tuning, on the other side, uses more and more project management text, like case studies, books, and others, for training in order to tailor the model responses to our specific industry needs. With labeled examples like risk assessments, the model learns to provide nuanced advice on project risk. This process ensures that the LLM applies its general language skills to the specific jargon and concepts of project management. Through human feedback, the LLM improves its ability to offer practical solutions for project challenges. Fine-tuning then enhances the LLM's performance, making it a more effective tool for project teams that are seeking fast, reliable insights. So, in essence, pre-training equips the LLM with a broad understanding of language, which is then refined through fine-tuning with project management specific data. This two-step process ensures that the LLM can provide valuable, contextually relevant advice for project managers and teams, enhancing decision-making and project outcomes. Now that the model has been trained, we want to see how exactly it goes about to generate text. For this, we are asking it to please complete this sentence here. The project manager tracks the project's progress against the ... Then we press enter, at which point the statistical and computational, let's call it a guessing game, begins, and the system looks up the first potential candidate, which is team morale. But as you can see, there is only a 3% probability that this is the right word. So that's probably not it yet. Let's now watch it do its thing. Next up comes scope creep, 4%, probably still not yet the right thing to do. Change requests, 6%. Moving on to stakeholder expectations. Okay, yeah, possible, but probably not yet it, 20%. Milestones, 50%. Okay, we're getting bigger and bigger percentages here. Then the requirements. Yes, you can do that against the requirements. Check progress. Budget, that would work. Checking the budget against the progress, or rather the other way around. Then the schedule, 85%. Okay, we're getting better and better here. What's next? We have the baseline. Obviously, yes, the baseline with 99% is probably the right word here. So great, we have found a word that fits into this context here. The project manager tracks the project's progress against the baseline. However, I must stress that what you have just seen is an absolutely massive oversimplification. While probabilities are important, LLMs don't solely rely on the highest probability word. They consider various factors as well, things like context or word co-occurrence and sentence structure, influencing the final selection. The scrolling format that I showed you, where the words are considered sequentially one after the other, also really doesn't adequately represent the iterative nature of the process. It goes through multiple iterations here. LLMs often consider not just the immediate previous words, but the entire sentence context and potentially even past sentences in a conversation to determine the next word. So, for example, if the previous sentence had mentioned that the schedule performance index was of concern, then the word schedule instead of baseline would have been better. Then there is the accuracy of the percentages that you saw, because that might also be somewhat misleading. An actual LLM prediction involves really complex calculations, which they don't necessarily translate directly to percentages that you and I can easily interpret. So I chose the percentages here to just simplify things. But given all of that, we most likely have the right match, because the selected word aligns with the common practice in project management of tracking progress against the baseline, which serves as the established reference point for project scope, schedule, and budget. And that brings us to the question, is a large language model a GPT? And yes, that's GPT as in chat GPT. We are asking this because we have learned just in this lesson that LLMs do create text output. But you're probably aware that GPTs are really, really good at generating text outputs. So are they the same? The simple answer is no. LLMs and GPTs are not the same. While both are involved in language processing and generation, they differ in important ways. LLMs are general purpose models trained on massive amount of text data to understand and generate human language. They can perform various tasks like text summarization, machine translation, and question answering, which means that LLMs on their own are capable of producing coherent and contextually relevant responses. On the other hand, a GPT, which by the way stands for Generative Pre-trained Transformer, that is a specific type of LLM architecture developed by OpenAI. GPT models are known for their effectiveness in text-generating tasks, particularly due to their transformer-based architecture. Or, as a Venn diagram, we have this here. They overlap. Therefore, GPT is not a mandatory component of an LLM. Many LLMs might utilize different architectures or training methods, including GPTs. But a GPT is really its own thing that has gained significant popularity for text generation due to its truly impressive capability in that area. Before I give you the takeaways, let me fast forward 15 years into the future to a time when AI and LLM have taken several more leaps in their capabilities, because that is when you can expect to see them provide adaptive project management coaching. At that time, LLMs will act as intelligent coaches for you and I, analyzing project progress, team dynamics, and individual performances. They then offer personalized coaching suggestions and guidance in real time, helping us adapt our leadership style, communication strategies, and even resource allocation based on the evolving needs of the project team. And for day-to-day tasks, they will serve as our on-demand mentors, offering tailored advice, sharing best practices, and providing solutions to complex project challenges based on a vast repository of their project management knowledge. But that's the future, and this is now where I'm giving you 4 takeaways. We've seen today how LLMs stand at the intersection of AI's revolution, reshaping our approach to data, language, and machine learning. These models are not just about processing information, they're about transforming how we interact with technology, making AI an integral, transformative part of our digital landscape. And then in the realm of project management, LLMs offer a new dimension of synergy, enabling more efficient planning, brainstorming, and execution phases. Their ability to understand, organize, and generate human-like text allows for unparalleled collaboration between AI and project teams, enhancing productivity and innovation. The essence of LLMs lies in their ability to learn from vast datasets, demonstrating the critical role of data in training AI. This again underscores the importance of not just the quantity, but the quality of data that we feed into these models, highlighting the dynamic relationship between data and AI performance. And then finally, preparing for the future means understanding and leveraging large language models within our projects and workflows. It's about building our own skills in a way that they align with AI-driven environments, ensuring that we are not just keeping pace with the technological advancements, but that we are able to harness them in order to drive project management forward. Yeah, and with that, we've come to the end of this lesson on large language models. Until next time.